This is Geometry Lesson 1 from Chapter 11. Chapter 11 will deal strictly with right triangles. And right triangles are any triangles that have one right angle. Now in Chapter 10 we learned that if we have similar triangles and we can know that because at least two angles are equal, and we know that all the angles are therefore equal. We know that in similar triangles that their sides are proportional. That's what we're going to apply to right triangles in Lesson 1. So on the top of page 429, if I have right triangle ABC, and if I draw an altitude from the right angle to perpendicular to the hypotenuse, that I now have three similar triangles. So I can say that triangle ABC is similar to triangle AOB. That's the one on the left, the small one on the left, which is also similar to triangle BOC. And then I can use the sides of these triangles and solve for unknown proportions, as long as I have that altitude. So now if I break this one triangle up into the three, and it does on your page, I'll leave this one as the big one. All right, so then rotating AOB around, I would have O is where the 90-degree angle is, B. And now rotating BOC around too with O in the air, it's easier to see it apart. I have BOC. All right, so AB is the hypotenuse here, AC is the hypotenuse here, and BC is the hypotenuse in this triangle. All right, so then I can look at some proportions, all right? I can say that AO in this triangle is, that proportion is to BO in this triangle, right, equals BO in this triangle, this leg, right, to CO in this one, all right? So the top one, I'm dealing with this triangle, right? And the bottom ones, I'm dealing with the slightly larger triangle, but the proportions should be equal, all right? So really, the smaller leg, notice that and in the previous chapter we learned about the extremes and the means, all right? So we can now see that our extremes, here's your extremes, rather, these are your means. That's your mean. So we can say that in this triangle, the smaller leg is the mean of the hypotenuse in this one. Look at BO. BO in both of these is the geometric mean between AO and CO, such that BO would equal, and this was on your last test, the square root of the length of AO times the length of CO. All right? Now, we can also draw some more conclusions. All right? Look at Corollary 1 to 49. In the middle of 429, it says the altitude to the hypotenuse, OB, see, it's your geometric mean. It's what we've just said. So the altitude of a right triangle is the geometric mean between the segments into which it divides the hypotenuse, AO and OC. All right? And we know that because we know the sides are proportional. All right? So the altitude is the geometric mean between the two portions of the original hypotenuse. All right? We can also say that AB is the geometric mean between AO and AC. And how do we know that? All right, let's look at a proportion here. Let's look at our proportions. I can say that AO in this one, in the smaller triangle, it's the shorter leg, is to AB in the largest triangle, right? So this is the smallest triangle. This is the largest of the three triangles, the original ABC. So this is this one is AOB, AOB, and this one is ABC. So the shorter leg in both of them is equal to the ratio of AB, which is the hypotenuse in the smaller one, over the hypotenuse in the larger one, AC. And so therefore we can say that AB, which is the shortest leg in the original triangle, is the geometric mean between AO and AC. All right, so what have we said so far? The altitude is the geometric mean between AO and OC. All right, and now we have said that the shorter leg AB is the geometric mean between the smaller leg and the entire hypotenuse of the big triangle. All right, so we're drawing some conclusions here. There's one more conclusion that we can draw based on the proportions. We can say BC, the longer leg of the original triangle, is the geometric mean between the other side, OC, and the entire hypotenuse. And how do we know that? All right, so if we're talking OC in this triangle, OC, so we'll call that the medium one. All right, so this is, we'll call that the medium triangle. I'll say M triangle. OC, and what is its corresponding side in the larger one? It's the OC is the longest leg, and in the big one it's BC. This is the largest triangle. Corresponds to BC, so that ratio should equal BC, which is the hypotenuse in the medium triangle, right, over the hypotenuse in the large triangle, which is AC. And you can see that BC in the large triangle is the geometric mean between OC and the entire hypotenuse. And that's what the corollary 2 to Theorem 49 says. Each leg of a right triangle is the geometric mean between the hypotenuse and its projection on the hypotenuse. All right, so I want to look at problem number 15 on page 431. All right, so this is 15 on page 431. And it has a large triangle, and here's the right angle, and then it has an altitude. All right? And this portion is A, that is 2, this one is X. Now I'm going to break these apart, these two triangles apart, so we can see them. You see the large one, and now we have AX, and I'm going to label that the hypotenuse, okay? X here is the shorter leg, okay? This is the longer leg. All right, then we'll look at the right side triangle. 2 is what? the shorter leg, right? X is, in this one, the longer leg, and here is your hypotenuse. All right, so now what can I say? Looking at this leg, 8, on this side is the longer leg. So this is the triangle on the left. All right, and here is your triangle on the right. This one, we'll put in the denominator. All right, so we're going to do a proportion, just like we've done. So 8 in this one corresponds to what side? X, right? I'm solving for X. The short leg in the left side corresponds to the short leg 2 on the right side. Cross multiply. X times X is X squared equals 2 times 8, which is 16. I solved this algebraically by taking the square root on both sides. The square root of X squared is X, and the square root of 16 is 4. X equals 4.